Call
degrees faster.
237563.
We now return to Super High on Modern Marvels. Much faster than a speeding bullet, NASA's next spacecraft, the Orion, will re-enter the Earth's atmosphere, generating super hot surface temperatures, over 4,800 degrees Fahrenheit. The extreme heat is created by friction, a force opposing motion between any two surfaces.
Friction is something which converts energy into heat. And worldwide, we spend 1/3 of all energy just to overcome friction.
At the Center for Advanced Friction Studies at Southern Illinois University, researchers are spending some of their energy studying the effects of the super hot temperatures generated by aircraft and race car brakes.
It's really severe, high temperature friction. While an airplane brake, it's more than 4,000 Fahrenheit. And in Formula One brake, it's 3,600 Fahrenheit easily in the race. Every situation generates friction.
It could be a saw cutting through wood, a submarine moving through water, or even feet walking on pavement. Before man knew anything about friction, he was using it to create fire. When it's time to stop a fast-moving object, friction is crucial, and with it comes some super hot temperatures. Slamming on the brakes of a 220-mile-per-hour race car means plenty of heat has to go somewhere.
You're putting a lot of heat very rapidly into these discs. Okay, so you're going to see temperatures exceeding 1,200 degrees C.
To endure these temperatures, the brake material of choice for race cars and aircraft is carbon.
It stays stable at extremely high temperatures, whereas steel brakes would fail at those high temperatures. They'd melt.
Different carbon brakes demand different carbon fiber structuring.
In Formula One, for example, the fibers are actually layers of cloth material, such as this. And what they do in order to hold these layers together is they press it. It allows for a three-dimensional axis. So now the heat can transfer from this surface to the inside very rapidly. These cooling vents allow for air to flow through them and pull the heat away from the brake material.
To put a full-scale carbon racing brake to the test, the center reproduces real-life braking on a machine called a dynamometer.
What you will see being tested is a NASCAR brake setup.
The brake glows red hot as it runs through the simulation. A thermal camera records temperatures at initial braking, sometimes called flash temperatures.
To simulate an automotive-sized brake, we have to cool it, because as you know, as you're moving, you have airflow going around that brake. So we have large cooling fans that are built right into the system that allow us to simulate the exact cooling rate that a car has.
The dynamometer runs the brakes through several cycles, imitating the repetitive braking that occurs during an actual race. Occasionally, they even test racing brakes to the point of failure to avoid them breaking apart on the racetrack. Down the hall, another dynamometer tests subscale aircraft brake samples. These subscale brakes are only about 1/100th the size of real aircraft brakes, but are a lot less expensive to test.
Almost 1,500. Wow. Look at that. Look at the smoke coming off of that. You hit 17 yet? Ugh, that's hot. That's hot. We like to push it sometimes to the limit, and that's important because the companies really want to know what happens.
Manufacturers such as Meggitt Aircraft Braking Systems take tests to the next level with full-size wheels, brakes, and tires. Their brakes may face their greatest test during a rejected takeoff.
You're moving down the runway at 170 miles an hour, and all of a sudden something fails. You got to stop.
Much of the energy needed for the stop goes to the brakes, causing rubbed surface temperatures over 4,000 degrees Fahrenheit. Within each brake system are multiple brake discs, either stationary or rotating. The intense heat starts where the discs contact one another and dissipates out within a few seconds. But fly at ease. Each brake design must go through hundreds of qualification and certification tests to make sure it's up to the task. There's a lot of friction heat when the tire hits the tarmac. But geologists feel heat of another kind when their boots meet a super hot Mother Earth. One large aircraft brake can absorb enough energy to stop 160 cars, each weighing 3,000 pounds and traveling 70 miles per hour. Super Hot will return on Modern Marvels.